Okay, so now I'm going to go over an example of home heating index. Really, I'm going to give you a partial example here, but I'm going to let you figure out some of the details, which you'll do in your lab today. So, as a review, home heating index gives you sort of a general indication of how efficient a building is. It's not a perfect metric, but it does give you an idea of the general level of efficiency. And over here is your scale from 0 to above 23. Sorry, my thing's in the way. 22. And the higher on the scale, the less efficient your building is, all else being equal. Okay, so that's kind of how it works. And then if you recall our formula for HHI, you take the total heating load in BTUs, you divide that by the square footage, and divide that by the heating degree days for that wherever you are. Okay, so the equation is pretty simple. But in order to get some of these variables, there's really only 3 variables here. It can be a little complicated, particularly for the heating load, so I'm going to go over the heating load part here. The square footage you can measure on your energy audit, or the information. You'll be able to find that out. HDD, I did post a video on how to find heating degree days for any place in the U.S., so feel free to look at that to find the HDD. So those two are relatively easy to find, relatively straightforward anyway. Now the heating load can be a little bit tricky, so I want to go over that. So here are a year's worth of utility bills, not bills, but the energy use by month for 1 year. Okay, so we have our electricity use in kilowatt hours on the top row, and CCFs of natural gas on the bottom row. So I want you to think about, how can we figure out the heating load, or the heating seasonal load of this building? Feel free to press pause and think it through, jot it down, and I'll give you one hint. It does involve a base load. So you need to calculate the base load in order to get the heating load. So go ahead and think about that, and when you're ready, keep going. So first thing we need to do is calculate our electric and our gas base load. Now this I've already went over in a previous video, but you take the 3 lowest months of electricity, the 3 lowest months of gas, you average them out, and that is your monthly base load for electricity and gas. Okay, so 483 kilowatt hours a month if you do the math for electricity, which is 5,800 kilowatt hours a year, and then gas is about 27 CCFs per month. These numbers are rounded, it's fine. Base load is an approximation, so you don't need to get crazy with decimal places. Okay, so now we have our base load. So how do we get our heating seasonal load? So what you need to think of is, okay, what are we using for heating in this house? And what I want you to think through is, which months are we heating the building? And I'm going to actually let you figure that out, because that's part of your lab, and I want you to think through it. But what I'm going to do is I'm going to give you an example. I'm going to take 1 month and calculate the heating load for that month. Okay, so let's look at December, right? So December down here, bottom right. Okay, so we have 1,050 kilowatt hours of energy use and 130 CCFs of gas use. So think about that. That is our total energy use for December. So what is our approximate heating load for each energy source in December? So if you think about it, it's everything that's not our base load, right? So remember, our base load is the energy we use every month, no matter what time of year it is, right? So for electricity, we're using about 480 kilowatt hours every month. That's our base load. So that does not include our heating load, right? So remember, base load is the stuff we use all year, and so if we're using 483 kilowatt hours in the summer, that's not for heating, obviously. Same goes for our gas base load. If we're using 27 CCFs a month no matter what time of year, so even in the middle of the summer, which means that that part is not our base load. Okay, so basically what you want to think is, the way you want to think of it is, anything that's not base load is seasonal load. But you have to be careful, is it cooling season load or heating season load, and that's what you need to think through. But for December, it's all heating load. There's not going to be any cooling in December, so all of our seasonal load is heating load. Okay? So all we need to do is take our total electricity use and figure out how much above and beyond our base load that is, right? And then same thing with natural gas use. So we have 1,050 kilowatt hours of electricity use. Our base load is 483 kilowatt hours, so that means our seasonal load in December was 567 kilowatt hours. That we will consider all heating load. Okay? So that's used for heating. And then for gas, 130 ccfs is our energy use. Our base load is 27 ccfs. So our seasonal load in December is 103 ccfs. Again, we're just going to assume that that's all heating. Like I said, this is an approximation, but it does give you a good sense. All right, so now we know our heating seasonal load in December, and we need to convert to BTUs. And all we do, that's really basic stuff. We've been doing this forever. You take your kilowatt hours, your conversion factor, CCFs, conversion factor, bada bing, there's your BTUs. So that is your heating load in December, or your seasonal load in December. In this case, it's the same thing, right? Because it's your heating. So you need to do that for all the heating months. I'm not going to do all the math for you. I want you to think through it because you're going to do this in your lab today. But if you work out the numbers for this house, now you can this isn't perfect because there's some assumptions that are made here. But if you do all the math, you take the entire, you do this basic process for all of your heating months, and then you convert to BTUs. You divide by your 1,500 square feet and divide that by 4,500 HDD. You end up with a HHI of around 8.8. And what that does is that tells you, you're right here on the scale, okay? It may be hard for you to read, but what that says is many opportunities to save energy and money and easier to find. Average homes with average insulation, average air leakage, and or average heating efficiency. So basically it's an average home. It's not efficient, it's not really bad, but putting on your energy auditor hat, and this is really the point, if you have an HHI of around 9 for a house, you think, I should be able to find some energy saving opportunities here. There's probably not great insulation. Maybe this heat, they're adding too much heat, or the thermostat's turned up too high, whatever the case may be. There should be some opportunities for savings in this house. And that's how you use an HHI. Again, not a perfect metric, but it does give you a sense of the overall efficiency of a residential building.